Welcome to Build Mystery, the place where machines, engineering, and innovation come to life. Before we dive in, make sure to subscribe and share this video with your friends, because what you're about to see is not just informative, it's eye-opening. From grains of sand to electricity flowing into your home, this is the unseen journey of how massive factories create solar panels. Stick with us till the end, because this story will change how you see the sun. From sand to silicon. Believe it or not, the journey of a solar panel begins with something as simple as sand. But not just any sand. It must be rich in silicon dioxide. This sand is transported to high-tech factories, where it's heated in electric arc furnaces at over 2,000 degrees Celsius. The result? Metallurgical-grade silicon, the raw material used to create the heart of every solar panel. But raw silicon isn't pure enough yet. It undergoes chemical purification through a process called the Siemens process, turning it into polysilicon, ultra-pure, and ready to become a conductor of sunlight. Growing silicon wafers. Polysilicon chunks are now melted again, this time inside a machine called a Czochralski crystal puller. Here, a seed crystal is dipped into the molten silicon and slowly pulled upward, forming a monocrystalline ingot, a single solid cylinder of silicon. These ingots are sliced into ultra-thin discs called wafers using a wire saw. Each wafer is as thin as a human hair, but holds the potential to capture light from the sun. Next, they're polished, cleaned, and chemically treated to remove imperfections, preparing them for the next stage. Turning wafers into solar cells, 330 to 530. Wafers are nothing without their ability to convert sunlight into electricity. To do that, factories use doping, introducing phosphorus or boron atoms to give each side of the wafer an electric charge. Then comes the anti-reflective coating, usually bluish in color, helping the cell absorb more sunlight and waste less. Finally, tiny metal lines called fingers and bus bars are printed onto the surface. These act like roads, guiding the electrical current produced by sunlight toward the output. The result? A solar cell, capable of generating clean energy when exposed to the sun. Assembling the panel. Now it's time to assemble the pieces. Most solar panels contain 60 to 72 solar cells. They're connected in series and arranged on a layer of protective material, usually EVA, ethylene vinyl acetate. A sheet of tempered glass is placed on top, followed by a back sheet at the bottom. These layers are then laminated together using heat and pressure, sealing the cells in like a sandwich. An aluminum frame is added to give the panel strength, and a junction box is attached at the back to handle wiring and connectivity. Testing and quality control. Every panel goes through automated testing lines. Flash tests simulate sunlight and check if the panel produces the expected amount of power. Infrared cameras scan for microcracks or hot spots. Even a tiny defect can affect the performance of the entire panel. If it passes all tests, the panel is cleaned, labeled, and packed, ready to be shipped around the world. The future of solar manufacturing. Factories are now getting smarter, using AI robots for precision, and even clean energy to power the manufacturing itself. Some companies are pushing the boundaries with bifacial panels. flexible solar films and perovskite materials, lighter, cheaper, and more efficient than ever. The goal? To make solar energy affordable, accessible, and everywhere. From grains of sand to a clean source of electricity, the journey of a solar panel is a miracle of engineering. This was Build Mystery, where we reveal the hidden processes that shape our world. Like, share, and subscribe to join us on the next exploration.